Hello, my name is Kristian Raue and I am a tech evangelist at Cedalo. Cedalo is the commercial sponsor of two Eclipse open source projects, both in the stream processing space. You probably heard about Eclipse Mosquito, which is the most popular MQTT broker in the world. That's one of our projects. The other project is called Eclipse Streamsheets. And Streamsheets allow to analyze and to visualize and manipulate streams that you have in, for example, the Mosquito broker, but also in brokers like the Apache Kafka broker or a REST-based data stream or AMQP, so you name it. So today I would like to talk about time aggregations. So how do you do time aggregations with Eclipse Streamsheets? So this is just a very short view in our documentation here. TABLE.UPDATE is the function that we are going to use. It's just a spreadsheet function, like spreadsheets function that you know, like average or sum. And this has, of course, some other arguments, and I'm not going to go through all of them in detail now. But one of them is interesting, and that is the possibility to sum up values in an aggregation table. So that's what we do now. The first thing you need, you've seen it already on the upper right corner, you need a data stream. So let's have a look at the data stream. We use the Streamsheet here to simulate a data stream from a wind power plant. And you can see that we have some random numbers here, so we have more or less wind. And we're creating a data set here. That's actually a JSON data set, which is supposed to be a payload for messages that we publish to this topic on an MQTT broker. But I'm not going to detail too much about this sheet. What I want to achieve is, and I show you this, is a table like this, especially this aggregated table here, where you have for each time period the sums for each of those turbines, and also have a chart for it. And now I would like to show you how we build a stream sheet like this in just a few minutes. That's how we do. So let's say we create a new app here, call it Table Demo. And you see that we have a selection of predefined data sources. In this case, I have a data source which is subscribing to the power plant. Basically, I just specified what the broker is and the topic and my credentials. That's how I create such a consumer here. And now press Add. And you see that we have a blank stream sheet now. If I go on this play button here, you see the data coming in. So that's exactly the same data that the wind power plant is producing. We have a 100 millisecond interval, could be of course a lot faster. Streamsheets can process up to 1 millisecond data streams. So we said we want to do time-based aggregation. So obviously we need a timestamp here. So I'm using a drag and drop feature to drag this field in here. You see it's a big number. So I'm just going to make this a little bit wider here. In addition to the time, of course, we need the power, which is currently delivered by the power plant. And inside the power plant, we actually have 4 turbines, so using the location field here. And so that's the raw information that we get. Now let's see how we can do aggregations. So in order to have aggregations, we need intervals. And there's an easy way of doing that. So I'm looking at 10-second intervals here. Of course, we have usually would have longer intervals like hours or minutes or so, but for the purpose of this demo, of course, we just take a very short interval. So how do we create the timestamps for the intervals? It's very easy. There's a function called integer. You all know this from spreadsheets like Excel or Google Tables. And we simply divide our timestamp by 10,000 milliseconds, which is 10 seconds, and then outside the integer function we multiply, and if you do this, then you get the timestamp for each of those 10 seconds intervals. It's a very easy trick, it's not a very complicated formula. Still, it's not really human readable, so what I do is I create a label that's more easy to understand, and there's an Excel type function here. It's called the text function. It allows you to convert a number into a text. So I'm converting the milliseconds into the Excel time format, which is a serial number, and then I just have to supply the format. In this case I want minutes and seconds, so this should be it. You can see that we now have our label in minutes and seconds. So that's it, and really that's all we have to do in preparation. Now we want the aggregation for each turbine, so we create column headers and use the autofill feature to achieve that quickly. And now I have the chance to use the table update functions. That's the function that we explained here, and I don't have to look it up here in the doco because we have an inline help. So if you type in the first letters of the function, you get table update, explains you what it needs. In this case, we will just specify the range, and of course we have to tell them which cell contains the value to be aggregated, and then we need to know which position of the table in terms of the row and column the data is supposed to be aggregated. So the row index would be the period, and the column index would be the turbine. Just one more information we have to add, that is how to handle if the table is filled with in this case periods. So we specify a -1 that tells the function to drop lines at the bottom of the table. That only applies to the rows. The columns we don't need to do that because we always have 4 turbines. And the very last setting we have is the number 9 here for the aggregation method. That specifies that the data is supposed to be summed up. And if I hit the enter key now, you see it immediately starts to add up the values, and that is done for each of those 10-second intervals. So in a few seconds we should see that you have a new line that will go all the way down here. Yeah, while we wait for the table to fill up, we might as well create a chart, visualize the data. You can see we have a variety of chart features here, not only the standard chart types, but also like something like a heat map or standard charts you can use if you have a time series. In this case, we simply use the stacked column bar. I have plenty of space here, so I highlight this range, and voila, here we have our chart. I can click on the title and call it total power production. I can even say 10 sec interval. So that is in here. And I see that here at the bottom, I'm running a little bit out of space. So I do a double click and rotate the data by, or the axis by 90 degrees here. So we have this information here. And now you can see that it's actually doing this. And that we now have all the data filled, and its wind is increasing, as you can see. Maybe with just one final step, you can very quickly format the numbers here, and we might want to have a different background color for the column headers here. So that's pretty much the same way as you would do it if you work with standard spreadsheet programs. Well, obviously you can see that the big difference is that we are able here to calculate with streams, so with how we call it unbound data, so data which doesn't have the first and doesn't have a last record. And of course, you could then use Streamsheet also to republish the data, the processed and aggregated data here to maybe a different topic. So that gives you the chance to very quickly just show that we have this function wizard here, and you can do publishing to MQTT, but you could also publish to a Mongo database or to Kafka or Influx. It could even be a HTTP server or use OPC UA. I'm not going to detail this very simply because I already showed you how this is done here in our data generator. So we're pretty much finished with the demonstration. You can see we really only needed a few minutes to build an application like this. Of course, this application runs forever. So if you close this, you would still see that the data is aggregating. So since the whole application is not running on a desktop, it's not a local application, it's a centralized application that runs as a microservice on a server. It could run on a server in the cloud, it could run on a server on the edge, on premises. So it's very flexible. It even runs on a Raspberry Pi. So we'd have a lot of flexibility here. Well, we're coming to the end of the presentation. Just make sure that you have a look on our website. So this is where we are at TABLE.UPDATE.com, and you have a chance to look at other blog entries that we have here, or you might want to go to our download page. So you can run it, since it's open source, you can download it for free, and they have a download page here. And of course, we have a community edition, but also a premium edition. So if you want some more enterprise-like features, happy to try out the premium version. And of course, we have support and documentation, everything online. Well, that's it for today. Thanks a lot for watching this demo. Stay healthy. I hope to see you soon. Bye-bye.